So, of course, we all know like Lustre is scaling up well towards the exascale computing, and there are a lot of developments happening around that area. So there are still a lot of entry-level users in terms of HPC starting for. So we could see a lot of them, especially in APJ region, still using NFS, right, and struggling in terms of the performance. Right? So we all know the basic difference of what NFS does and what how Lustre can make a difference out of NFS. But at the same time, what's the reality? Right? I mean, when we looked into the requirements in detail, we investigated what exactly the challenge, why did we have to go for the Lustre. So the feedback what we got is like Lustre is still an alien for us. It's a big elephant to bite, right? Because there are multiple factors in terms of cost, or in terms of power consumption, less capacity, more throughput, scalability. So, so these are the challenges what currently they have. Then later, we thought of like more than go in a theoretical way. Let's start looking at what our Lustre system is up to in a small scale. Right? So that's the background of this small factor solution. So let's start looking at what are our observations in terms of running a small form factor Lustre solution with HPC workloads against NFS. So this is how the traditional minimum Lustre solution looks like. We all know, like we need 2 MDS servers and 2 OSS servers. A minimum cost of 4 servers along with MDPs and OSDs in the back end. So this looks good, very scalable, traditional, works well, but at the same time for entry-level HPC clusters, it's really challenging because in terms of the hardware cost or the software cost, or in terms of the InfiniBand ports or any high-performance data network ports, right? Because this solution needs minimum. That's one of the major challenge, what we are facing with that. So on the left-hand side, you could see the sample rack layout. Again, it is completely sampled. Nothing, related to a specific solution as such. But over here, we have considered like a 2 rack unit where it has MDS, OSS, and set of disks on MDTs, OSPs, and of course we have InfiniBand or the gigabit switches as well. Right. So this is really challenging because how can I accommodate compute and a storage within a rack for an entry-level solution? So that's how it is started. So here it comes. So there are many ways to optimize the solution, but one of the best way that we found is like to optimize it within 2. Because of course, MDS or OSS just looks for a OS instance to run with. So there are many ways to optimize, but at the same time, we took the simple route of having just 2 servers. One is MDS and another one is OSS. Just work on a HA mode, right? So this evaluation, though we have options for both LDiskFS as well as ZFS as a backend file system. This evaluation is completely based on ZFS because of many reasons in terms of data integrity and other stuff. But still, LDiskFS, it's still doable with LDiskFS as well. So if you look at again the rack layout on the other side, it is still compact. It takes less power, less rack layout. So it is much better than what we have seen before. And so this is the low-level architecture of the one which we have seen in the previous slide. So while like ZFS is more of a software-defined architecture, that's where a low-cost JBots could definitely help. I mean, in terms of cost reduction, as well as the better features of ZFS could help over here. The OSTs and MDT and MGT comes from the either from the same JBot or from a different JBot. again, like it just a reference architecture. We just thought of providing a baseline comparison between NFS and a Lustre solution in a compact factor. But at the same time, this reference using this architecture, it differs. The performance or the features will differ with respect to the underlying hardware. So you could see a heartbeat link for the HA purpose of it, and there is a management network only for the management if we are using the Intel manager for Lustre for the monitoring or management purpose, and there is a data network as usual, which could be InfiniBand or OmniPath or whatever. Okay, so this is a traditional scalability of Lustre, where we just tested the how it can be scalable further. Where you could see the first one, which is the basic building block of having one MDS and OSS. Like moving further, scaling further, we can have multiple combos of drives and legacy servers or legacy storage as usual, which is typical. Whereas we look at the NFS side of it, though the option of ZFS allows us to scale further, but the limitation is still within one server. We cannot go beyond a server. As an overview, it's very low cost, small footprint integrated with Intel Enterprise Edition Lustre. Of course, though this evaluation is based on Enterprise Edition Lustre, still we have an option to replicate with Community Edition as well. No single point of failure. Failover enabled because we built some special HA resource agents to handle the ZFS export and import, or maybe the IP link failure in the backend, or maybe like sometimes the OSTs or MPPs mount as read-only for no reasons, where we don't have a track of it. So these agents will be looking to those areas and do failover based on those failures. Right. Scale out with performance within the same namespace, and there is an option of using Intel Manager for Lustre for the monitoring purpose. So we have used a test bed, right? So the idea over here, or the objective over here, to compare NFS and Lustre apple to apple, because though we are talking about NFS lags behind in terms of cache coherency or I/O as a bottleneck, or in terms of scalability, etc. We keep talking about that, but what's the reality? I mean, that's where this exercise has started. Using the same bill of material, use NFS and use the same bill of material for Lustre as well, and see how does it work. Right. So this is what we have in our test bed. So we used most of the Intel white boxes, Intel servers with 128 GB of memory, and it's like pretty old generation CPUs. Like we use standard rich processors, and some of the Intel JBoards. We got like 4 Intel JBoards with running 1 TB SAS hard drives, right? And we use 6 GB SAS links. This is pretty previous generation, the setup. But at the same time, our idea is to just provide a baseline comparison between NFS and Lustre. So there is no actual performance numbers behind this evaluation. So we had like 2 different Z pools, or 2 different categories of Z pools. We used MDT and MGT, as in a mirror strike mode. We used only 4 SSDs for the MDT and MGT, and we used about 88 SAS drives in 8 different RAID Z pools with dual parity, right? So we had about 8 different OSDs on the Lustre side of it. Right? From the ZFS, like we used the one which is bundled along with the Enterprise Edition Lustre, that is ZFS 0.6.5, and we used the typical CoreSync pacemaker along with the Intel developed HA resource agents to handle the ZFS export, import, etc. Coming to the NFS, you could see the same setup, right? Two NFS servers instead of MPS and OSS with the same bill of material, not much of change, and we use one of the NFS HA agent as well to handle the export and import. So it's apple to apple, same test bed, right? But from the NFS perspective, we had only one large Z pool because in terms of the single namespace, that's the only option available within ZFS. So we used all 88 or 80 hard drive, SAS drive, in the same Z pool for this comparison. So these are our results on the OBD filter survey because we would like to understand like what are the storages up to and what are the performance that we get, the bare metal performance that we get post formatting, like at the ZFS level, right? So in terms of write, we got about like 5 gigabytes of write performance as a peak, and 5.7 gigabytes in terms of read, right? And coming to IOR, right? You can look at the left-hand side, which showed the write operations. So NFS scores better while while running with a single thread or a dual thread. But scaling up further, Lustre can scale much better than NFS. So we were able to get about 94% of the write efficiency from the storage using Lustre while we scale up. And in terms of read, yes, the same there. We were able to achieve about 25% of better performance than NFS. So we use the same workload, same command, same benchmarking tool, which is IOR, to do a fair comparison between both of them. And this is what we're looking at. Right. Lustre performs better when it scales more. So in terms of metadata operations, we used MD test, and we first you could see the file and directory creation removal operations. Again, here Lustre scores much better than NFS. So here are the start operations, but as per our evaluation, NFS scores better than Lustre because of many reasons. Of course, there are a lot of work going on to improve the metadata performance in terms of stats, not only with ZFS, with LSKFS as well. At the same time, when you look at the test bed comparison, we had only 4 drives for the MDT versus 80 drives on a NFS Z pool, which actually makes a difference in terms of the start operation. All right. Another one is the sync operation, right? In terms of TXG for Lustre, that is something really making a block for the start operations, which we are working on currently, and we expect the next release to have much better metadata operations with Lustre based on ZFS. So this is the overall results. We got about 57% better performance in terms of write and 25% better performance in terms of read operations. 94% storage efficiency, and file creation, file removal, like it's about 2.5x and 8.8x improvements, and up to 8.45x directly creation and removal. So the support for high availability, manageability, and in terms of scalability, Lustre performs much better than NFS. Yes, some of the design considerations, in terms of this is generic to a ZFS, not specific to a small form factor solution. So I think we actually observed that SSDs, we get good performance while we use it for MD. And over here, like we have used 8+2 configuration for individual OSPs, whereas it's completely based on RAID Z2. So rather than triple parity, dual parity is good in terms of performance, right? And sufficient memory on MBS and OSS. It's all because of the ZFS ARC caching. Right? And disable auto failback. This is again a suggestion. Okay, so there is a background to it. While we designed the small form factor, as of now, the reference architecture, it says that one MDS and one OSS. While people were asking questions why both can be OSS and add the MDPs to your OSS. Yes, so that can be done, but at the same time the failure time or the recovery time at the client will be more when the server which has got both MDPs and OSTs gets failed. So considering that, considering the failover time and the recovery time, we prefer or we suggest to go for one MDS and OSS, which is the most preferred way. So the auto failback stuff, it's more about which is by default enabled with pacemaker and chorusing, which actually makes the things unstable while you enable it. What happens is the NBS goes down, so it got failed over. Again, once it comes up, again it gets failed back. Right? So this will go on until it gets stable. So it would be necessary to find out like if it is stable, then do a manual failback. So that's what it's all about. Feature works optimize on stats performance, which work is going on, and optimize single thread write performance, not only single thread, on dual thread as well. So we are still working on it. We are still working on optimizing the ZFS level configuration and tuning to improve the performance on single thread and dual thread. And optimize small file performance. I'm sure like everybody is behind that. While we compare to NFS, yes, small files performance is much better with NFS, but at the same time, we are evaluating several other solutions to improve the small files performance as well.